Dr. Ranjani Partha is a professor in the Department of Information Science and Technology, Anna University. Her area of specialization is computer architecture and networks. One of her special interests is Indian language technology systems. She is actively involved in research in all the areas and has over 50 publications to her credit. She has about 25 years of experience covering both industry and academics.
Welcome to the UGC lecture series in computer science. This is a series of lectures in computer networks. Today we will be looking at digital transmission systems. So, as part of digital transmission systems, we will have an introduction to ISDN. ISDN stands for Integrated Services Digital Network. This is one of the first technologies with respect to digitizing the telephone network. So, and it has been designed such that it integrates both text, audio and digital data transmission. Okay. So, you could have data transmission, audio, image, video transmission, all these together. So, it is basically a switched digital telecommunication line that can be delivered over regular copper wires. So, this is what is very important here, that is there existed copper wires through which our analog communication was taking place, and when there was a necessity to integrate the digital transmission along with that, you wanted to do it so that you could deliver the digital communication over the regular copper wires. So, ISDN was a technology which was introduced for that purpose. So, we will take a look at the details of this ISDN technology. Okay. So, with this basically what we end up achieving is that we are able to provide end to end digital communication, that is from the device, from the sender to the receiver, all through, that is from here to the local station that we talk about, and from the local station to the end station, and then finally to the end receiver. It is all end to end digital communication. Okay. So, typically this is a scenario that we would look at. So, I could have a switched or a packet switched network in between. I have an ISDN box which allows me to connect up different telephone lines, which means I am talking about audio communication. I can also connect a PC to this ISDN device, and through this I can have an end to end digital communication. Okay. So, examples of ISDN applications are typically for on off ramp to the information superhighway to communicate at speeds of 128 kilobits per second for a single ISDN line, and you could also combine multiple ISDN lines to achieve higher communication speeds. So, this is basically to allow both home users to connect up to the internet and use the available digital, access all the digital data that is available, and also for the business world to provide remote access to LANs. So, you have starting from a lower bandwidth to all higher bandwidths which can be supported for both home users as well as business users. You have a range of services that are provided by ISDN. Okay. So, if you look at ISDN connections, how do I get an ISDN connection? ISDN connections can be obtained from a local telephone company in the same way that we obtain an analog connection. Okay. So, the phone companies offer different types of ISDN connections. The basic characteristics of ISDN basically is in terms of what we call as B channels and D channels. So, you have what are called as B channels, they are 64 kilobit per second channels that are used to carry data. So, these are the B channels, and then you have a D channel which could vary from 16 to 64 kilobits per second, and this is used for signaling purposes. So, by having different combinations of B channels and D channels, ISDN provides you different services. So, if you look at the service connections that ISDN provides, primarily there are two services. One is called the basic rate interface or BRI, which is used for home or SOHO connection. SOHO stands for single office and home office. So, you are kind of looking at sitting from home and working. So, you are looking at simple office connectivity that you could have. So, these kind of users typically will use a basic rate interface. So, you have what is called as the basic rate interface, and then we have something called primary rate interface or PRI. So, we talk about BRI and PRI, two different types of services provided by ISDN. Now, PRI is normally used for large businesses. So, that is the basic difference between these two. Okay. So, we will see that the difference basically comes from the fact that for home usage you are happier with lower data rates, higher data rates are required for businesses, they would go for PRI. So, if you look at the constitution of BRI and PRI, you can see what is happening here. If I take a BRI, the basic rate interface, it basically consists of 2 B and 1 D channel. There are 2 B channels and 1 D channel. So, as I said, B channels is 64 kilobit per second. So, if I combine 2 B channels, I get 128 kilobits per second, and it uses a D channel of 16 kilobit per second, giving me a total data rate of 144 kilobits per second. So, this is the data rate that I get with a BRI. A PRI on the other hand will use either 23 B channels or 30 B channels and 1 D channel. 23 B channels at 64 kilobits per second plus 1 D channel of 64 kilobit per second will give me an aggregate data rate of 1.544 megabit per second, which actually is the equivalent of a T1 carrier. Now, a T1 is a digital carrier that is used again in digital communication, and this supports data rates of 1.544 megabit per second using time division multiplexing. So, that data rate is achieved here using 23B plus 1D channel, or if I am using a E1 standard, which is a 2.048 megabit per second data rate, this can be supported using 30B channels plus 1D channel. So, 30B, which is 30 into 64 kilobit per second plus 1D channel, and that will give me the E1 data rate of 2.048 megabit per second. So, depending on whether we are in Europe where we use the E1 channel or other places like the USA where the T1 standard is used, we could get the same equivalent by using either 23B plus D or 30B plus D. So, the PRI kind of caters to both T1 and E1 standards. So, we have the BRI and the PRI as the two bases, the two interfaces or two different services provided by ISDN. Okay. So, now we will look at some details of these different services. So, as I said, we have this B channel. Now, where does this name B come from? B basically stands for what is called as a bearer channel. So, B channels are also known as bearer channels, and they are the ones which carry information, that is which carry the data. The D channel is known as the delta channel, and it is used for signaling purposes. So, we have B channels for the data, D channels for the control information or for signaling purposes, as we say. Okay. So, when we talk of a 2B plus 1D channel service, that is what we have as our basic rate interface, and it can go up to 192 kilobit per second. I gave you an example of it using 144 kilobit per second. If the D channel also is a full 64 kbps channel, then I can go up to 192 kilobit per second in the BRI service. Okay. So, if you look at a simple BRI connection to a computer, this is what it will look like. So, you will have what is called as an ISDN terminal adapter that will have to be used. Now, this terminal adapter can be connected to a computer as well as to a regular telephone line. So, I can use it for my voice as well as for my data. And this ISDN terminal adapter would be connected to what is called as a network terminator of type 1, which is NT1 as it is referred to, and this will be connected to an ISDN BRI line. Okay. So, as I said, the B channel is a 64 kilobit per second channel, and two B channels can be inverse multiplexed or basically bonded together, so that we can get a maximum aggregate communication speed of 128 kilobits per second. The D channel, as I said, is a 16 kilobit per second, or it can go up to 64 kilobits per second. The entire bandwidth is really not used for signaling purposes, which means you can use that excess bandwidth, typically an excess of 9.6 kilobit per second is available for packet switched data transmission applications. So, I could use this excess bandwidth for things like climate control, security alarm systems and so on. So, I could use the additional bandwidth is available in the D channel for other purposes as well. So, that is the flexibility that is available in the D channel interface. Now, coming to the PRI service, that is the primary rate interface service. As I said, this is much more sophisticated service compared to the BRI service, and it offers either 23 B channels plus 1 D channel or 30 B channels plus 1 D channel. We will understand the technology is similar. Whether it uses 23 B or 30 B depends on whether it is trying to provide compatibility with T1 or E1 standards. So, we will understand with the 23 B plus 1 channeling mechanism. So, if we look at the properties of the B channels in the PRI transmission service, each B channel operates at a speed of 64 kilobits per second, and they are used for carrying data, and they can be combined together to increase the aggregate communication speed. Okay. So, again if you look at the property of a D channel, each D channel operates at a speed of 64 kilobit per second, considerably faster than the D channel in BRI, and the 23 B channels share a D channel for signaling purpose. Okay. So, this D channel is shared among the other 23 B channels. As I said, PRI channel is delivered over a T1 line. T1 speed is 1.54 megabits per second. And you can see that the aggregate speed of PRI from all the 23 B channels and the single D channel is computed as 23 into 64 plus 64, that will work out to about 1.544 megabit per second. Okay. So, if you look at the sample services that are typically offered by ISDN, we said you can have home ISDN. Home ISDN is offered as basically as a BRI connection, 2B plus 1D. Charges are typically cheaper during off peak hour. So, you are charged either per channel or per minute, that is the kind of services that ISDN would provide you. You can also have what is called as an SDS 56 service, which is single channel switched digital service, and it will give you about 56 kilobit per second. This is another option that you have with the ISDN. Okay. Now, if you look at the way the adapters would be used, so you can just take a look at this. So, this is my public switched network. This public switched network could be connected by means of multiple NT1 termination equipment. Now, I will shortly come to what I mean by these different NT1 and these kind of terms that we are using here. But right now, look at it as some terminal equipment that we have here. Now, this will be connected to the ISDN adapters, okay, and the computers or a phone would be connected to the ISDN adapter. Now, this public switch network could also be connected to a computer by means of an analog modem. So, you can see that the public switch network will allow you to connect both ISDN networks as well as the regular telephone networks. Okay. So, that is what we see here. Now, if I am looking at remote ISDN access to a LAN, so you can see how the whole setup will then look like. So, what I would have here is I have an Ethernet LAN here, right, which is a 128 kilobit per second. Let us say I have transmission here. This could, I can have the LAN connected by means of a 128 kilobit per second line to an ISDN router. This ISDN router in turn now would be connected to a NT1 device, which is a remote. Okay, this would act as a remote ISDN bridge. This can be connected using the BRI service to the public switch network. This, of course, on the left side I have here the instance of a single device connecting up over here. So, a single device could connect up using ISDN adapters through NT1 using BRI service to the PSN, and from here I will be able to access the Ethernet LAN through the ISDN router here. Okay, this is another possibility that we have. These are different configurations that you can very easily come up with the ISDN facility. Okay. So, remote access typically can also similarly can also take place over PRI. So, we talked about remote access over BRI. This can also happen over PRI using the primary rate interface. When we use this, of course, the device that you see here is different from this. You do not use an NT1 device, but we use something called a DSU or a CSU. Okay. And we use an ISDN router here, which allows you to connect to the Ethernet. So, depending on what kind of connectivity you have, we need to use the different ISDN devices. Okay. So, if you look at important features as such of the PRI connection, primary rate interface connection, you can have communication links between remote computers and this LAN, between this LAN and remote locations, this LAN and other remote LANs. All these are possible with the help of different types of devices that we have. So, the link is established using a powerful ISDN router. Okay. Now, coming to this the different components of ISDN, we talked about NT1, NT2 and so on, right. We talked about NT1. Similarly, we have something called NT2, and then we also talk about something called TE1. Okay. These are terms that are used in ISDN, and you can also see that there are some alphabets here, S, T, U and so on, R, S, T, U over here. Now, these are interfaces that you have between these different devices, and there are standards which describe what these interfaces will look like. All this forms part of the ISDN standard. Okay. So, you will have, for instance, a TE1 device, could be a computer. This is basically a terminal equipment device. It could be either a computer or it could be an ISDN telephone or a standard telephone. Depending on what kind of device you have here, they would connect up by means of different types of interfaces to the different types of equipment, and these equipments in turn would connect up to an ISDN switch, which would be connected by means of a packet switch network or different a switch network or a packet network or a private LAN network to other ISDN devices. Okay. So, these are the various components as such that we have in the ISDN system. Okay. So, we will take a short break now. We will come back and continue with the details of the components of ISDN. welcome back after the break. We have been looking at ISDN services. We talked about two services, the basic rate interface and the primary rate interface, and then we have been looking at the different components of ISDN. So, we will look at the details of the components of ISDN now. So, as I said, ISDN components, we talked about something called TE1. TE1 basically stands for terminal equipment of type 1. Okay. Now, this basically is an ISDN compatible device, that is, it could be a router with an ISDN interface. Okay. Now, these TE1s, they connect to the ISDN network through a 4-wire twisted pair digital link. Okay. And we also have another type of equipment called TE2, which is terminal equipment type 2. Now, these are used for ISDN non-compatible devices, that is, devices which are not compatible with ISDN use a TE2 type of equipment. Now, these devices, they will require a terminal adapter. Now, this terminal adapter will be the one that will allow you to connect to an ISDN device. So, it provides the compatibility as such. Okay. If you look at, then you also have another device called a component called the terminal adapter, TA. Now, this terminal adapter is used to convert standard electrical signals into the form that is used by ISDN. So, this is needed when you are connecting TE2 type of devices. So, this is so you will have a TA connected to a TE2 device and then connected to the ISDN network. So, the ISDN TA, it could be either a standalone device or it can be a board inside a TE2 device. So, I will have a TE2 device. Before the TE2 device can be connected to an ISDN device, it needs a terminal adapter. So, this terminal adapter can be another device in itself or it can just be a board inside the TE2. Now, the TE2 could be just a computer. Okay. So, but within that device you can have a board which provides you this terminal adapter facility, which will allow you to convert the electrical signals standardly that are used normally to that which is used by ISDN. Okay. So, this talks about the terminal side equipment TE1, TE2 and TA. Okay. Now, coming to the network side equipment, we talk about network termination devices, which are called again network termination type 1, where we have what is called as the NT1 device. Now, here this device again, it connects the 4-wire subscriber wiring to the conventional 2-wire local loop. Okay. So, basically provides that interface. Now, again this is a customer premises equipment, okay, in which case we refer to as a CPE device, customer premises equipment, that is, it sits on the customer premises. Okay. Then we have something called network termination type 2, which is NT2. So, now this is an intelligent device that performs switching and concentrating. Okay. So, this provides for multiple devices, multiple ISDN interfaces to be connected to an ISDN line. So, the NT2 may be as simple as a bridging device connected to an NT1 unit, or it may be a very complicated private branch exchange, a PBX kind of a device. Okay. But this is the one which allows you to connect up multiple ISDN lines that we talked about. So, you can just take a look at the reference points that we have. Now, we talked about different devices, right. So, you have a TE1 device connected to an NT2 device and then connected to an NT1 device, and then we talk about these different reference points R, S, T, U and so on. So, these reference points basically are a series of specifications that define the connection between the specific devices depending on their function in the end-to-end connection. Okay. So, we can see it more clearly over here. So, I am talking about a TE1 device. As I said, TE1 devices are ISDN compatible devices. So, it can be a computer which is ISDN compatible, or it could have a telephone which is ISDN compatible. Now, this connects up to an NT2 type of device. Okay. Now, the NT2 device, the interface that you have between TE1 and NT2 is defined as a S type interface. Between NT2 and NT1 will be a T type interface. Between NT1 and an ISDN switch will be a U type interface. Now, if I have a standard telephone which is not an ISDN device, then it is a TE2 device. The TE2 device connects to a terminal adapter by means of an R interface. Then the terminal adapter now connects to an NT2 device by means of an S interface. So, from this point onwards, these two become very similar. The terminal adapter basically allows you to bring it to the ISDN mode, then you have the same kind of setup which is connecting up to the ISDN switch. Now, if we look at the different ISDN layers and protocols, now we talked about the different channels and the basic connectivity that is provided by the physical line and the data rates which are handled by these physical lines. Now obviously we are not looking at ISDN as just a physical carrier, but it also we also need to understand how the different layers of the network are handled by ISDN. So ISDN defines layer 2 and layer 3 protocols that are to be used on the B channel and on the D channel. So here again there are a number of different numbers and standards that we use here. So layer 1, whatever we talked about now so far, basically is defined by what are called as I.430, I.431 and ANSI T1.601, some standards which define the layer 1 characteristics. If you look at layer 2, now remember layer 2 typically talks about data link control and so on. So on the D channel we make use of a standard called LAPD, the LAPD protocol that is used, link access protocol on D channel. So it is called as a LAPD protocol, and then we have similarly on the B channel we could either use LAPB, which is link access protocol on B channel, or I can use HDLC protocol or point to point protocol or frame relay. All these are different technologies that can be supported on the B channel. So we could use any of these as a layer 2 protocol. Layer 3 protocol, B channel I can use IP or IPX, internet protocol that is. On the D channel we use something called DSS1, which is defined by Q.931 standard. This is a protocol specification. Okay. So these are basically the different channels, I mean the protocols supported at the various layers for the two channels that we have in the B channel and the D channel. So to summarize, this is basically what we need to look at, right. So B channel and D channel layers. So as I said, layer 1 we have already taken a look at how the different rates are interfaced. Okay. In fact, we will also see how the multiplexing takes place at layer 1 shortly. But as I said, layer 2 we have these two options. D channel has a different set of protocol, B channel has a different set of protocol, and at the B channel multiple options are provided: HDLC, PPP, frame relay, LAPB and so on. Okay. Now coming to the BRI frame structure, now PRI also will have a similar structure, but it is easier to understand the BRI frame structure because it only has 2 B channels and 1 D channel. So you can see how the transmission takes place. Again, a time division multiplexing is used, and from the terminal equipment to the network type device, from TE to NT a particular frame structure is used, and from NT to TE another frame structure is used. So you can see what the various bits which constitute a particular frame as such. So there are 48 bits in each frame, okay, and these 48 bits are repeated every 250 microseconds. Okay, so that will give you our T1 data rate that we talk about. So you can see what we have here. It starts off with what we call as a frame bit, okay, F bit, which is the framing bit, and then there is something called a DC balancing bit, an L bit. Then we have the B1 channel. Now this B1 channel is the, remember that in B we have two channels, right, B1 and B2 it's referred to as, and B1 and B2 again they are 16 bits are carried per frame. Okay, so you will have 8 bits here and another 8 bits here in this B1 channel. Similarly B2 and B2, 8 bits here and 8 bits here. So altogether 16 bits per frame for B1 channel and B2 channel. Okay. And the D channel there are 4 bits per frame. You can see where the 4 bits are. So you have a D bit here, a D bit here, a D bit here and a D bit here. So there are 4 D bits that are provided, and when you have so this is your transmission from TE, from terminal equipment to the network termination device. So I will have B1 device, I mean B1 bits, then there is an L bit which is called as a DC balancing bit, which is provided in order to balance the DC component on the line, then again a D bit, then L bit, then there is something called an FA bit which is an auxiliary framing bit which is used, then you have again L bit, then again bits from B2, L, D, L, B1, L and so on. Now when you have data coming from NT to TE, we also use something called an echo channel bit, that is in addition to the D you will also find one E sitting in over here. So this E bit is supposed to be a echo of the D bit that was transmitted from TE to NT. So you will have these E bits coming here, there are 4 E bits that we have. Okay. Then there are a few spare bits also which are provided. Okay. N is always set to the opposite of FA, basically to balance out on these two sides, and then M is used when you have multi-framing. Then of course there are also a few spare bits which are used. So this you will find as the frame structure of a BRI frame, basic rate interface frame. Okay. So, you can see that it basically uses time division kind of multiplexing with equal weightage for the B channels, and D channels only 4 bits are provided per frame. Okay. Okay. Now, let us look at how the call setup typically happens using this ISDN protocols that we talked about. Okay. So, to establish an ISDN call, the D channel is used between the router and the ISDN switch to control functions such as call setup, signaling and termination. And then we use something called signal system 7, an SSS signaling is used between the switches within the service provider network. Okay. Now, typical call setup procedure will look like this. So, a calling party gives a setup message, a setup acknowledge will be sent back here along with the call proceeding tone, which indicates that the call is in progress, right. Now, when the setup is received here, this setup will be sent to the called party. Now, that will respond with a call proceeding message, which actually is passed on to this side, okay. And then an alerting signal will be sent to this, right, and that alerting signal again will be given as a feedback to the calling party. Then this gives a connect signal, right. So, this connect, the once it is connected from the other side, this will give a connect signal, this will respond with the connect acknowledge to the service provider, right, to the switches over here. Similarly, a connect acknowledge is also given to the called party. So, this is what happens on both sides. Okay. So, you can look at the series of messages as such. So, when you pick up from the on this side, the calling side DTE, that is the data terminal equipment, will send a setup message to the network. That setup is passed on to the other side. Meanwhile, a local setup acknowledgement is sent over here. Any information that is passed here gives you back a call proceeding message, and once the other side is connected, you send a ringing message over there. When a ringing message is sent there, an alerting message is sent to the network, and when the person picks up, then it starts the connect procedure, because unless you pick up you can't connect, right. So, the moment the other person picks up, then a connect message is sent. This connect is sent back to the router, and this will stop your ring back indication. Once you have done this, now an acknowledgement is sent. So, once an acknowledgement is sent, your connection setup is complete. Now, information can start flowing. So, information flow happens, and similarly we also have a procedure for disconnecting the call. So, this is what happens in terms of the call setup and connection up. Okay. So, to summarize, what we have looked at so far are various details of the ISDN the digital transmission mechanism. So, as we said, it is a switched digital network. There are two different types of services provided by ISDN, which is BRI and PRI. BRI is 2B plus 1D, 2B channels plus 1D channel. PRI primarily provides 23B plus 1D, it could also provide 30B plus 1D. And we have also looked at various ISDN protocols and standards. So, questions to review the contents of today. Question number 1, what does ISDN provide? Question number 2, what are BRI and PRI? Question number 3, what are D and B channels? Question number 4, how is a non-ISDN equipment connected to the ISDN network? Question number 5, how does a call setup typically proceed in ISDN? Thank you.